day everyone, welcome to my channel BST African Electronic Surgery on a Wednesday. Let's fix something. This is coming from a rural tech. Yeah, even people in rural areas, they are trying to fix things there. So the technician opened the TV and he bring this motherboard for repair here. And he knows the fault. So this must be a very quick job because already the customer know the fault, but we are not sure if that is the only fault, because if we check here, yeah, the board is not, the TV, he said is not turning on, is not doing anything. But if you check here, you can see we do have the AC circuit, and before the big filter capacitor, that is the rectifier and it's blown up. You see that rectifier is blown up. So we have to see how we can fix this. We have to see how we can fix this quickly. The board is plugged. We must have standby light here, and we don't have any light. It's just dead. Even if we press the power on switch, nothing, just dead. The first thing, let's check the AC input voltage, 200 something volts. $220, you can see on the screen, 220. We jump and go to the big capacitor. We must have 300 something volts, and we have 0. You see, 0 volts. So what you have to do, let's unplug here, and let's check this big capacitor. 0. Yeah, that's the first thing that we have to do on this switching power supply, just to make sure that we are safe. So our visible problem is that this bridge rectifier blown up. Why did the bridge rectifier blown up? Let's check for big capacitor for short. No. On the switching MOSFET. The MOSFET looks good. We do have some diodes here. And our input fuse is here. I want to check for that fuse. Now looks weird. The fuse looks good, the MOSFET looks good, but the rectifier is blown up. My question, which I don't have an answer, is how did this rectifier blown up if the input fuse is too good? Do you have like a hidden short? You know what? The power supply is set around 11 point something volts. Let's check. Let's apply voltage on the big capacitor. No, 4.2 amps. Need to lower the current. So coming with the 12 volts on the big capacitor is not taking any current, like short. Okay, maybe we'll lack this time. Maybe we'll lack this time. All what we need is to look for another bridge rectifier. I do have boards for space. What about this one? This one, the rectifier is missing. We have another one. What do you think about this? That's the rectifier. That's our rectifier. So either we'll see an explosion, or oh, this looks smaller and this one is bigger. We can't put this rectifier because the size of the rectifier bridge looks different. Maybe let's take down the rectifier. Maybe we can. Maybe we can. That's the blown up rectifier. And this rectifier. Let's see if we can do some magic to let this rectifier I think we can. Despite the size, I think we can. So what we need here, we need soldering wire. We need to put more solder so that the bridge rectifier will sit properly. Hopefully, I'm not creating a bomb here. I just hope so. That's the rectifier. Now the rectifier is now in place. Let's check for short. On the output, AC, because you don't want bad things to happen here, so you have to make sure. The problem is I don't trust the multimeter, because in most cases it's showing me no short, but there will be short there. Okay, so all what we need is to test to see if this board is working. That's all what we need to do here. See our rectifier. Do you think we are lucky? So how is everyone? Let's just wait for the board to cool down and then we can test. So how is everyone? I'm very happy. People, they are supporting the channel. They are following the channel. They are trying to learn, to share knowledge. You know, this channel, everyone has to participate, has to contribute something, because this is not a one-man band. I started this channel for you guys. It's not actually my channel. It is our channel, because if you share what you have and I share what you have, what I have, probably we have a better platform with the professional technicians in the future. So don't think this is a one-man band. No, this is not my channel. This is our channel. This is our platform where we are just sharing electronic knowledge and experiences on how to fix and how to treat different situations from different motherboards with different behaviors. So that's the thing. I still watch. That's the thing. We're not even try. I'm not even trying to 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 direct the channel the way I want to know. You also have the upper part to contribute what we have, and then we try to move the channel further. So yeah, that's the thing. You know what? I like TV repairs because 99% of the power issues, they are fixable. If I'm to give advice to someone to start the repair things, I would say start fixing TVs. You see, the, despite the board, the screen, the big screen, that's the only engine that we have. They combine the logic board and the switching power supply together. Everything is very easy. What you find, like a common force on these Chinese boards, you find a fault, a bridge rectifier, you find this switching MOSFET can be fault, you find a fuse can blow up. What else can be fault? The optocoupler can be, and the TL431 shunt regulator TL431 shunt regulator, which I believe is this one, which looks like a small transistor. This, that's the TL431 shunt regulator for the optocoupler, and the driver, this 6-leg small. That's the worst case when this driver is faulty, and especially from my end here in Africa, you can't get it. You have to find a way to treat the situation. So let's now plug the power. And we have light. I can't believe, this is the first time to see a TV board with such simple faults. So why did you say, people, they are trying to fix things. You know what this guy came to me saying? He said my TV, this TV came from my customer, is not working, but there's a blown up chip. But I don't have this kind of chip. He failed to recognize that this is just a simple rectifier bridge. You can even replace it with this like diodes, with the normal rectifier that we know. Maybe I have one. Let me see. You find different configuration on this rectifier bridge. You couldn't recognize this. You see this rectifier? It's just the same with this one. It's doing the same job. But this technician failed to recognize that this is some kind of rectifier bridge also. It's just changing AC to DC. So we do have the standby light. You see this light? Let's power on. Which one is the on button? On. It's changing to green. Off. It's now off. On. It's now on. Let's check some voltages. Let's check down some voltages which give us satisfaction that this board is working for sure. We must have backlights voltage. And we don't have. What? 35. 36 volts. This is going straight to the LEDs. So we have backlight voltage 12 volts, 11.98, 12 volts is present. We do have the EPROM IC on the last pin. That's the VCC pin. We must have 3.3 volts. And we have 3.33 volts. EPROM BIOS, whatever you call it. And we do have some coils. We must have 5 volts for the standby. 5.21. So this board is now working. On the big capacitor, what do we have? We have 303 volts. And the board is still on. You see the light? The green light. So Yeah, I know the reason why this guy sent this board for repair, because he clearly explained that I don't have this chip. Do you have this chip which is blown up? This is just a simple rectifier bridge like this one. So even if we replace this bridge rectifier with this, the TV will still work the same. You just connect the AC input, these two mid wires, and the plus and minus on the output, and still you still have a working board. So yeah, that was just a simple repair. Like, subscribe, don't forget to turn on the notification bell. See you on the next game. Bye.